Most people view minerals as optional additions to a modern diet. Something you can compensate for later. That assumption is biologically incorrect. Minerals are not nutritional accessories. They are the inorganic architecture that every cellular process depends on. When these elemental systems are neglected, enzymes lose stability. Electrical signals lose precision. Structural integrity begins to fail. This analysis examines the full spectrum of essential minerals, from macrominerals that shape the body, to trace elements that fine-tune every chemical reaction. You will learn to recognize the human body as a mineral-dependent engine. Subscribe to continue your systematic study of human biological requirements. 1. The macromineral infrastructure. This system exists to provide the structural mass and fluid pressure required for physical integrity. The function of this system is to maintain bone density and osmotic balance across cell membranes. Calcium serves as the primary building block for the skeletal frame and cellular signaling. Phosphorus works in coordination with calcium to harden the bone matrix and store chemical energy. Magnesium acts as the system regulator for over 300 enzymatic reactions. Sodium and potassium manage the electrochemical gradients that allow muscles to contract and neurons to fire. Chloride maintains the necessary pH balance and fluid volume within the system. Without this system, the physical framework of the body loses its mechanical and electrochemical stability. 2. The trace mineral catalyst network. This system is responsible for the precision tuning of metabolic and hormonal functions. The function of this system is to provide the specific metallic ions required for enzyme activation. Iron is the central component of the oxygen transport system within the blood. Zinc coordinates the structural stability of proteins and regulates immune signaling. Copper facilitates electron transfer and supports the formation of connective tissues. Manganese functions as a critical cofactor in the metabolism of carbohydrates and amino acids. Iodine drives the thyroid system, which dictates overall metabolic rate. Selenium enables antioxidant enzymes to protect cellular structures from oxidative damage. If this system fails, the chemical signals required for coordinated metabolism become slow, inefficient, and unstable. 3. The electrolytic conductivity system. This system exists to facilitate the transmission of electrical signals through biological fluids. The function of this system is to ensure that neurons and muscle fibers communicate instantly. Sodium maintains external fluid pressure, while potassium governs the internal cellular environment. This delicate balance creates the voltage necessary for every heartbeat and conscious thought. The coordination between these minerals prevents the collapse of cellular hydration. Magnesium acts as a gatekeeper, ensuring electrical excitation does not become excessive. When this system is disrupted, the body loses its ability to transmit information, maintain rhythm, and regulate movement. 4. The trace element regulatory core. This system is responsible for long-term metabolic health and genetic stability. The function of this system is to support minor but essential biological pathways. Molybdenum assists in the breakdown of toxic compounds within the liver. Fluoride integrates into the mineral structure of teeth to resist mechanical degradation. Chromium enhances the action of insulin on glucose uptake. Each of these elements is required in microscopic amounts, yet remains non-negotiable for system longevity. Without this system, the body cannot efficiently manage waste, nor maintain structural durability over time. You now understand that minerals are not dietary preferences, but the foundational architecture of the human biological system. This inorganic framework provides the environment in which organic systems like vitamins and enzymes can operate. In our next analysis, we will examine the synergistic relationship between minerals and fat-soluble vitamins. This is why mineral intake is not a matter of preference, but a biological imperative. This system exists whether you acknowledge it or not. Thank you for watching. Continue your analysis by selecting the next video on your screen.